Alright, so just a reminder about how this works. I interrupt Abby while she's doing her homework and I show her a joke. And if she laughs at the joke and holds up one of these smiley faces, then you get to see it. If she doesn't, you'll never see the joke ever. So far, 100% success rate.
Pretty good.
This is like a joke for year 11 and 12s. So because you're only 13, you might not get it. Okay, you ready?
Yeah, I'm ready.
Huh? I love this joke, but Abby doesn't get it. Oh no, Abby. Which face are you going to pick? You think it's bad or you don't get it?
I just don't get it.
Wasn't it that one? Sorry guys, you're never going to see that really funny joke that I love. That's the end. Thanks everyone. Hello again, grade 5-6. Nice to see you today. Today we're going to do an experiment with a different kind of chemical reaction. We're moving away from yeast now. You've been doing that for 3 weeks. Let's move on to something else. So today I want to talk about a kind of chemical reaction called oxidation. Now usually you don't really have to learn about this till high school, but we're going to give it a crack today because you have proven yourselves to be very capable. Now oxidation technically is when electrons, which are part of an atom, switch between atoms to different molecules. But we're going to talk about it in a more basic sense of what it used to mean, which is just when oxygen reacts with something to produce something new. So sometimes this can be a good thing, sometimes it's not so good. And you might know some examples already from your own lives. So first of all, I want you to think about when you have seen something rusting. That orange kind of crunchy looking stuff that appears on metal, you've probably seen it. Rust is a type of oxidation, and it often means that the metal corrodes or wears down over time because the rust gets into the metal, the oxygen reacts with it, and it changes it into something new, breaking down the metal. So I'm just going to go around my garden and take a few photos of different things that I have rusting in my garden to show you. I have another example of rust all around me sitting on this deck actually, and it's the wall of this deck that we have made of steel, cortan steel, and cortan steel is actually designed to rust. You want it to rust because it has a pretty pattern and you get that orange kind of color to it, and designers for gardens and things really love this happening. So that's one example of where rusting can be a really good thing. So when we talk about rusting, it only refers to that orange color that you get when iron oxidizes or rusts. Okay, so I'm going to show you the reaction for that now in molecules in a little drawing so that you can see how the iron changes into what's called iron oxide, and that is that orange stuff that you know. In other metals, we don't call it rusting, but they do the same thing. They also oxidize. So if you have silver in your house anywhere, I don't know if you've noticed, but over time, silver turns from beautiful and shiny to this kind of dull looking, almost black, kind of tarnished surface. And this is also oxidation. Oxygen mixes with the silver or reacts with it, and you end up with silver oxide. I have a picture of one of my little silver butter dishes in the kitchen to show you what that looks like. And a third form that you're probably all really familiar with is to do with copper when it oxidizes. So oxygen reacts with the copper, which makes copper oxide. And this is beautiful because you might know that copper is an orange colored metal, but when it oxidizes, it turns green. It is beautiful. If you've ever watched a show on TV by Kevin MacLeod called Grand Designs, then you'll know about how people use copper in their buildings. They use it to make their roofs beautiful colors. Flinders Street Station has a roof that's made of copper and has gone green because it's oxidized. And probably one of the most famous landmarks in the world, the Statue of Liberty. and she was actually deliberately built in this color so that it would oxidize and turn green over time. Now, just a little extra bit of information that is not to do with oxidization. You might notice that her torch is not oxidized in that photograph. The Statue of Liberty's torch was specifically made out of a metal that does not rust and does not corrode and does not oxidize, so it would always be that beautiful color. And I believe that metal is gold.
Whitehorse students radioed in to help Danielle and Sunny solve the mystery of how huge aeroplanes can stay in the sky. These were some of the responses. Danielle and Sunny finally made their way to board the aeroplane to Tasmania. A friendly air hostess met them at the stairs. Sunny assured her that he didn't have a pocket knife anymore because security had taken it, but could he maybe have it back again once they got there? Danielle had bigger questions to ask.
Excuse me, please. How do such big things like aeroplanes stay in the air? Is it because of wings?
Excellent question, young lady. I suppose you're wondering why gravity doesn't just make them come back down to Earth again, right?
Yes, they are very big, and Sunny here thought maybe it was to do with the wind, but it's not always windy in the sky, is it?
No, you are very right. Aeroplanes have two things they need to keep them in the sky. The first is a very strong force to make them move forward. That's why we have these huge engines here. The fans spin really fast and that pushes the plane forward. We call that thrust. Sunny looked thoughtful for a moment. But wouldn't that just push the plane into those bushes down at the end of the runway? Well, that's why we need the second force, which we call lift. This force happens when the aeroplane starts moving very fast and the air molecules push onto the wings as they rush past, causing the plane to lift up in the air. And with that, the mystery was solved. Did you figure out how big things like aeroplanes stay in the air?
So metals aren't the only things that can oxidize. Other things can too. So when you have a fire is oxygen reacting with something to make fire. And so that is also an oxidation reaction. So the word gets thrown around a little bit, I suppose. Today we're talking about food when it oxidizes. Okay, so truly one of the most annoying first world problems I've ever had is that when my mum used to make me lunch, which was actually quite a bonus, and I'd go to school, she would cut up my apple into quarters, and by the time I went to eat it, it would be brown. I don't know if any of you have faced this same dramatic experience. It's really frustrating because I don't want to eat brown apples. Most people don't want to eat brown apples. And brown apples are caused by oxidation, which we've just been talking about. It's where oxygen reacts with something in the apple to make it go brown and kind of gross, let's face it. So today you're going to do an experiment which will help you in future when you have cut up apples and bring them to school to find out, is there a way that we can stop our apples from going brown? Now, heaps of people have ideas about this. I've read that you can put lemon juice on them, but wouldn't that just make it taste disgusting? You can put them in water, but then you've got water in your lunchbox. So I don't know if any of these ideas work. That's what we're going to do today. You're going to get an apple, you're going to cut it into quarters, you're going to put it into different things, and we're going to see if any of these strategies work, and then you're going to have to eat it and see if it tastes good, if they do work. So we need to find a manageable solution to the cut up apple problem. And if you work it out, you get extra bonus brownie points from your teacher being very impressed, because you could help me with a lifelong problem that I've had. All right, let's get started. Okay, for your experiment today, you need to have an apple. That's the main ingredient. And the other things you can use whatever you like. I used vinegar, lemon juice, a stuff called citric acid, and some water because I just had them lying around the house already. Now, I've just added a little bit of water because citric acid is a powder and that makes it a little bit hard to spread on the apple, so you can see me adding some water here. Now, on the internet, there are lots and lots of different ways that people suggest you can stop oxidation of fruit. These are 4 that I had heard of. I've heard of some people using orange juice, so like from a bottle, some people trying lemonade, all kinds of things. If you've got any of those things lying around your house, feel free to go with whatever you have in your house. Now, I need you to cut that apple into relatively even sized pieces to make it a fair test. And we're also going to have 1 slice of apple that goes on the plate that we're going to do nothing to it. So it's our control piece. So we can compare all the other solutions to that one. So there's that piece of apple, control piece, sitting on the plate. And you'll be able to use that later to see if there's any difference. I'm brushing some vinegar onto this slice of apple here, and then I'll put it on the plate in a different position. Then get some lemon juice and squeezing that onto another one. I found it easier actually just to put the piece of apple in there and roll it around a bit rather than brushing it on. And then same thing for the last 2 solutions. So citric acid. I don't even really know what citric acid does. I just found it in the cupboard. And lucky last, just one with plain water on it. Now, once you've done this, it's a good idea to make yourself some labels and put them around the plate so you remember which one's which. And then I just want you to check on them every maybe 5 to 10 minutes or maybe after an hour and just see, can you see a difference in the rate that they go brown and that they're oxidizing? So this is what mine looked like when it was all set up. If you choose, you can also do a different experiment, like does temperature make any difference to the time it takes for an apple to oxidize? Or does the amount of air that the apple has on it make a difference? You can choose what you would like to do with this and let me know when you find something out. Today I want to tell you about Fu, who was an orangutan who lived in Omaha Zoo. And this is all rhyming so far. How good's that? All right, I've drawn a picture of Fu, high quality. And one day the zookeeper came in to find that Fu was up in a tree. Now, this would have been fine, except the tree that he was in was not in his enclosure, and he'd also managed to take away 3 of his babies and another orangutan with him. So there's 5 little orangutans sitting in a tree outside their enclosure. The zookeeper was a bit mad because the door was open, the maintenance door to the enclosure, so he went and told off all his zookeeper staff for letting the orangutans out. Anyway, a couple of weeks later, they came into the zoo and found Fu and his little family sunbaking on the roof of another animal's enclosure, not in his own enclosure, a second time. The zookeeper was furious, thinking that one of his keepers was just leaving the door open and not being careful enough with locking it, until someone caught him in the act, actually escaping. It was nothing to do with the zookeepers at all. And what he'd been doing was he'd been climbing along these louvers of an air ventilation shaft thing in his enclosure. So those are like those little flat louvers on windows that go up and down like that. And he'd been climbing along that and then getting down into the dry moat that went around his enclosure. Now, if you've ever been to the zoo, you'll know that a lot of enclosures have like a concrete kind of pit right around the front of them. especially things like orangutan enclosures. Anyway, he managed to climb along the air vent louvers down into the pit, and then they saw him at the maintenance door, and what he did was he pulled the bottom of the door, really, because he's pretty strong, pulled the bottom of the door out so it was wedged open a little bit, and then got this piece of wire and lifted it up into the crack and managed to undo the latch on the other side of the door and got out. So finally they knew how he was doing it, but the funny thing was that this wire that he had, they didn't know where it came from. He just managed to find it somewhere, and he had been hiding it in his mouth. So he shaped it in the shape of his mouth, and it was sitting like behind his lip, in between his lip and his gum with the teeth in it. That's where he was hiding the wire, and he just hid it there for weeks, or as long as he needed to, and then just pulled it out to pick the lock, and then got out of his enclosure. So what an awesome orangutan. Seriously, that is so clever. Okay, so that's Fu.